Hi, what we're looking at here is a NuTone Series 2 8-note long tube chime bass from 1939. Earlier I did a little video about servicing the motor and gear drive assembly. I wanted to do a brief video about this. This is not going to be a servicing video because I already have done a servicing video on this style of chime bass, but there were a couple things I wanted to go over in this video because we have an opportunity that we haven't had before. This bass came from a customer in Mississippi, and her house was built in 1940, and the way it's set up is it has a single doorbell button at the front door on the front porch, but then also in the house it has two pull cords. There's one in the dining room and I think there's one in the living room, she said. You know, the kind of pull cords you would see in an old time black and white movie, and the lady of the house would pull the cord and then the servant would come and find out what she needed. In this particular house, this is set up so the front door rings the 8-note Westminster chime, but the pull cords ring as if they were rear door and side door, so you get a single note, which I thought was kind of interesting. The other thing which is interesting and unusual is when she bought the house, it actually came with a copy, or perhaps I think she has the originals, and these are copies of course, of the installation instructions. How about that? How often do you get to see original NuTone installation instructions from NuTone Chime Incorporated, 3rd and Eggleston Avenue, Cincinnati, Ohio, from 1939 or 1940. This chime is pretty certainly 39 because there is a date stamp on the gear drive assembly, so I'm pretty confident that's when it was made. This has been completely repaired. Like I said, it's not a repair video. There will be a few videos upcoming about some of the work I did on the individual parts of this type of chime, but this video is more about the instructions because we don't get to see something like this very often. And I will scan these and clean them up, and I'll post them on our website, and there'll be a link down below in the video description so you can go and see them in their entirety and download and print them out if you're interested. This particular chime is installation for installing and wiring a NuTone Majestic 4 4-tube cathedral door chime. And this was the top of the line model when it was new. And it was fairly expensive, I have a feeling. And we have a note down here. It says, "You have a beautifully styled and finely engineered chime when you buy the NuTone Majestic 4 chime. Tell your friends about it. We'll appreciate you doing so." Because this was very early on in NuTone as a chime manufacturing business. They had only been in business for about 3 years at this point, and I'm sure selling every chime they could was very important. I'm not going to go over all of this, but we're going to go over some of the fine points because I think some of the things are interesting. You have a brief description. It's operation and adjustment of the chime, what happens when you push the front door button, how to adjust the chime. And what you have to remember is this type of chime, this was a new idea back in those days. You know, we take this for granted nowadays. Everybody watching this probably either has one of these or knows somebody has a long tube or some kind of more elaborate chime in their house. But in 1939, it was a new idea. It certainly wasn't the common farmhouse buzzer that most people had, or a door knocker, or I guess nothing at all. The thing that's most interesting that I wanted to go over is on the second page, and the second page is instructions for installing and wiring. And I am going to show you how a chime like this wires up. There is a diagram here on the second page that shows the transformer and the wiring. This is not really drawn very well, and it's a little bit confusing the way they drew it, and so I'm going to elaborate on this so you can have an idea how to do that. One of the important things that we learned from these instructions is this chime bass has a place for a light bulb. It's a light bulb socket, and then you have this pull chain on the side to turn on. Essentially it's a decorative or a night light or an accent light. And people ask me all the time, what kind of bulb does it take? And it's like, I don't know. All the ones that we see, either the bulb is missing or it's got some replacement bulb, and who knows if it's the right one or not. But here we have clearly in the instructions that it says has a 24 volt number 1477 bulb, and 1477 is a fairly common miniature bulb part number. We're actually going to order a bunch of those, so we'll have them in case somebody needs one, or if we need one for a customer. We're going to order those, and we're going to send this back to this customer today probably, and we'll send her a light bulb as soon as we get them in. Here we have a drawing of the chime mechanism, and I'm pretty sure based on how this is done, this is probably the engineered drawing of the chime that they probably used when they filed a patent on this, because it looks very much like a patent drawing from what I've seen before. One of the things that they talk about in here is that this is a 20 volt chime. It works on a 20 volt transformer. It says make sure the house current is 110 volts, 60 cycle AC. This chime operates on that current only. And there is a lot of the onlys in these instructions, and I think NuTone was being a little hardcore about this because this was again a new idea and they wanted it to be installed properly, and people were not used to doing something or having something like this, and who knows what the average person or I guess electrician or somebody might do with something like this. So they're pretty firm in their instructions. They're not pulling any punches on telling you what to do and what not to do. It talks about how to route the wires in and so on and so on. And then up here we have a drawing of the parts on the outside of the chime, which I find interesting because they're all labeled and they're identified as to which is which. We have down here about attaching it to the wires to the posts inside, which I'll show you. And it says to check the chime before the box is closed, first adjust the volume control. Volume control is here, and I'm going to show you on the real one also. On the front of the plate, move the volume control to the Y position, all the way down to the soft position, figure 2. This will prevent the springs from being knocked off the plungers. Plungers are P's, before the tubes are hung in place. So this style of chime uses, you have the 4 electromagnetic solenoids with the 4 plungers inside, and then if you open it up, here are the plungers right here, and you have springs that sit against the bracket that hold the solenoid in place, and the wide end of the spring sits against this bracket, and the small end of the spring fits into a groove that's in the end of the plunger. And these are compression springs, so when it's energized, the plunger shoots out and it compresses the spring down, and then when it shuts off, the spring pops it back again. The point of what they're telling you is, and I actually played around with this and it's not uncommon, in this style of design, if you were to take the spring off, unclip the spring off the back of the plunger will simply fall out of the front. There's nothing to hold it in place. It's the spring that's doing all the holding. In every sense, until you hang a tube on here, the tube is actually the stop for the plunger, because the plunger pops out and hits the tube and then the spring pulls it back inside. If you don't have a plunger in place and the plunger is energized at its full strength, it rockets out of the solenoid so strongly that it can knock the spring out of the little groove in the back of the plunger, and the plunger goes arcing across the room and rolls across the floor. And also it can over compress the spring and bend the spring so it's not the right length anymore. So I think they were being very practical when they told you that you should, because we all know that if somebody bought one of these, they're going to be all excited about it because it was expensive and it's a new idea, and they're going to be the first house in their neighborhood probably that has one. And of course, when you finally get it hooked up, you want to know if it works or not. And if it's at the wrong setting and the plungers strike too hard, they're going to shoot out, it's going to roll across the floor, it's going to damage the chime, something probably is going to happen, and then of course they're going to go, well, this thing's no good, and then they're going to take it back to where they bought it and want their money back. So I think NuTone was being very practical about trying to instruct people early on how to deal with a mechanism like this, because it was a new idea. And we're going to talk about that, how to set this up. The other thing is it talks about what happens when you push the front door button. And I like this part down here where it talks about, it says after you've tested the chimes and so forth, if, however, it does not operate perfectly, turn immediately to the last page of this folder. And we don't really have the last page. So the last page probably had instructions about to contact NuTone or go back to where you bought it or do something to calm the customer down because they're pretty certain at this point they got a defective one and they're going to do something about it. Unfortunately, we don't have the last page. It says after testing the Chime, close the Chime box, replace screw C. Screw C is up here. It's the screw that holds it closed. And again, move the volume control, Y, up about halfway. Hang the longest tube on the extreme left as you face the Chime. Continue this all the way until you have the shortest tube on the extreme right. Hang the tubes in the grooves on the support. That's E. So these are the supports. And you have these little adjustable knurled hanging thingies that the cords hang on, and it allows you to move the tube in and out away from the plunger to adjust how it sounds. Hang the tubes in the grooves on the supports E. These supports can be adjusted by turning them on the screws, bringing the tubes closer to the plungers for a louder tone or further away for a softer tone. So what that really means is, the way you have to look at this is, there's a balance on this. There's a balance between where the tube is actually hanging on the adjustable part and in relationship to where you have the volume in quotes, adjustment set for how hard the plungers are going to strike the tubes. Of course, if you have this cranked all the way up to maximum and you have the tubes way too close, it's not going to sound right. So there's a balancing act, and what they're trying to do is they're trying to get you to start at a reasonable level, which is about half, and then adjust the tubes to get it to sound proper. Because the way you have to look at this is a musical instrument. It may have a motor and be automatic in some ways, but it's still a musical instrument. It's not very much different than a xylophone. You have tubes, you have resonator tubes, or in the world of clocks, my friend Marv tells me that they're referred to as bells, not tubes. But you have, it's all mechanical. It's like a musical instrument. So you have to tune the chime. You have to try to get it so it sounds right. And unfortunately, I think even then in 1939, and definitely today, everybody always wants to crank everything up to full because full's best, all full power. Got to have it boom, boom, hit real hard. That's not right. It's really got to be more delicate than that. And I go, almost every single service call I go to in people's houses where they have any kind of long tube chime, not usually this old around here, but most of them are from the 70s, 80s, 90s, and in that time frame, they always have it cranked up to full, and they don't need to. It can be less than that, and you can actually make it sound better. So you have to be reasonable about how to do this, and I think a lot of these instructions had to do with trying to get people to be reasonable. So let's finish reading this and then we'll go over the actual chime. It says, number 8, press the front door button again. If the signal is too soft, move the tube closer to the plungers by twisting the groove support, number E. If a still louder tone is desired, move the volume control Y up further to the top. So see, they're having you adjust the tubes first in an attempt to get the right amount of volume before you start cranking up the voltage to the solenoids to make the plungers hit harder. With these two adjustments, it's easy to get the proper volume. Remember that if one tube signals differently from the other three, that individual tube may be adjusted on its own support. If you find it necessary to make an adjustment of this kind, remember that the tubes do not signal from left to right in order. The longest tube gives you the lowest tone, the shortest tube gives the highest tone, because the tubes don't strike 1, 2, 3, 4. There's a different order to how they strike to make the Westminster chime. And it's not obvious until you stand there and watch it a dozen times and figure out the proper order, which I'll let you do because I'm not going to tell you. Finally, slide the plastic cover over the chime case and your chime is completely installed. The night light operated by the gold pull cord, and it was a gold pull cord. I actually have seen a picture of a real one. It was a braided gold cord with a little tassel-y thing on the end of it. Very classy. The night light is operated by the gold pull cord, works like any other lamp, may be switched on or off at will. Again, this is the important part, and anybody who's watched any of my chime videos, this is going to sound really familiar. May we again caution you, they're being very polite. Your NuTone chime never is bold, italic, never needs oil of any kind. And if it is oiled, it will be damaged. Have you heard that before? I think you have. Maybe here, I'm not sure. And the factory will not be responsible. Also, smaller case italic writing. They're not going to, because you know, the first thing that happened, oh, we'll put some oil in it. You know, it's good for the tractor, so it's probably good for the chime too. Things haven't changed that much. These instructions are valid today as they were in 1939. So if you have one of these, download this and read it. And if you fix your chime, or you're just interested in tuning it up so it sounds better, follow the instructions. They know what they were talking about. They were building chimes in 1939. This might have been written by Mr. Corbett himself. I'm sure he sat in on the writing of this with the engineers, and they said, well, we got to do something with these consumers. They're driving us nuts. We got to give them instructions so they don't mess it up. So let's take a look at the actual chime. This chime was a good repair. It had a lot wrong with it. Now it works just like I want it to. The most important thing, one of the things that was wrong with this chime in particular, is this assembly right here. This is the volume adjustment assembly that they talk about in the instructions. And this little knob right here moves up and down. So you can see now it's in the middle, and I can move it down to a lower volume and up to a higher volume. Of course, according to the instructions, you start, when you have no tubes, you start way down here just to make sure it works. And when you finally hang your tubes, you start somewhere in the middle. So what does this do? Well, this is a piece of non-conductive insulated material. I think it's some kind of Bakelite, or it could be some kind of really thick piece of mica. And I'm going to do a video about this specifically. The wire that's on here, this is nichrome wire. Nichrome wire is resistance wire. It adds resistance into the circuit for the power that comes in here, goes through the wire, and goes back out down here. And it adjusts the amount of electricity that each solenoid receives. So if you put it down here, there's more resistance, so the voltage is lower. If you put it way up here, there's less resistance and the voltage is higher. Now, what happens to these is nichrome wire is the same kind of wire that you have in your toaster. And if you ever looked inside your toaster in the morning when you're making a couple English muffins, you'll see it in there, and it's a little wire, and when you turn the toaster on, it glows a reddish orange color and it gets really hot. But surprisingly enough, it doesn't ever break or burn up, because nichrome wire is used for heating elements and things like that. So not only is it a resistance wire, but it's also a good heating element wire. And over the years, because if this is 1939, it's almost 80 years old, over the years, with all the heating and cooling as the chime is rung, it does one of two things. Either the wire itself breaks, and if you have a break in it, the chime doesn't work, or the heating of the base material over 80 years, it slowly degrades the material and it all falls apart. And I'm going to do a video about that. The important bit is replacing the nichrome wire is tricky, but it can be done. But the important thing, which they don't really talk about in the instructions, but I think it should go without saying, is when you move the little adjustment knob, you need to do it carefully, because if you don't, you're going to scrape the wire too much and push them around on the base material, and ultimately, if they touch, it's a short, and it shortens the total length of the wire, which makes it get too hot, which makes it overheat and burn up and cause all kinds of problems. So I'm going to show you how I think this should be adjusted so those kind of problems don't happen. So here's our volume assembly, and here's the little brass knob that you move up and down, and it slides in the slot here and here of this brass strap. And the brass strap is attached to a screw down here at the bottom and has one of these little acorn nuts on it, and there's a lock washer underneath it to hold it in place. The brass strap is springy, so if you carefully do this, you can see it moves. So when you go to slide this, what you should do, in my opinion, even though it's not stated clearly in the instructions, but at this point, there's a difference between what the instructions say from 80 years ago to what we're dealing with today, 80 years later, because 80 years is a long time for any kind of mechanical device, and while they're a very well made and robust type of mechanism, it's 80 years old, so a little bit of extra care goes a long ways to not creating more problems, because we're not trying to create more problems, we're We're trying to solve problems when we fix one of these. So what you should do is, if you're going to move this, if you're going to slide the little knob, what you should do is pull up on it, to pull up the strap a little bit so you're not scraping the little contact point underneath the knob right here. You're not scraping it across the surface of the wire as much as you are sliding it over the surface of the wire and then letting go, and it goes back down and touches the wire. So it's a little hard to show you because it's so small. Maybe we can do it this way. I'll use the little needle-nose pliers to keep my big fingers out of the way. So now what I'm doing now is I'm pulling up on it and I'm going to slide it down. It's a little hard to do with the pliers. And I'm going to slide it down and leave it there. And now, of course, oh, that's not loud enough. We need to have it louder. So again, I'm going to move it up, but I'm going to pull up on it. So I pull it away from the wire and I'm going to slide it up. That's really hard to do. So you're just going to have to trust me. I'm pulling up on it, away to move it away from the wire, and then I sit it back down at the point I want it. That prevents it from scraping across the surface of the wire, and you won't damage the wire, and you won't push the different individual strands of the wire together and make a short, which effectively shortens the total length of the wire, which changes how it actually works. And while you may not believe it, this little piece right here, from one end to the other, this is about 3 inches long. And altogether, there's about 1.5 inches of the 3 inches that has wire wound on it. And it goes around and around and around, so it's on all 4 sides. And you may not believe it, but there is actually a little more than 4 feet of wire wound around on this. And you need to have that amount of wire so you have the right amount of resistance when it's all done. Now what I'm going to show you is how you wire up a chime like this. So if you open up the chime, this is the part that sits against the wall, and it has these 2 keyway slots, and you would put screws in your plaster and lath wall and then hang it. And this hole right here is where all the wires would come through. Up here in the top, there are 5 screw terminal connections, and this is where all the wires are going to terminate. And these, just like these, have the same little knurled nut assemblies as are used for the tube hangers on the front. So let's go ahead and look at, I'm going to show you how this would get wired up. So here's our representation of our door chime. Here's our 1939 NuTone Series 2 8-note chime base, just like the one you just saw. We have the 4 solenoids with the plungers here. We have the contact assembly here with the revolving arm. Here's our volume adjustment, our little resistor assembly. And here are our 5 screw terminals. Now, the screw terminals are inside the case, but for the purposes of this demonstration, I drew them on the outside of the case because it's easier to draw the wires all in instead of them getting all bunched up inside the housing. So they're inside the housing, but I'm showing them on the outside so it's easier to show you. Also, we have our transformer here. The transformer is 20 volt AC, not DC, AC, and I believe it should be rated at somewhere around 30 watts. I don't have an exact wattage rating, but based on the size of the transformer, I believe it's probably 30 watts. And then we have our 3 push buttons. We have a front door button, a rear door button, and a side door button. So here's how we wire it up. Our 4 terminals are numbered 1, 2, 3, 4, and 5. And the key for them is 1 is the common connection, 2 is the front door connection, 3 is the rear door connection, 4 is the side door connection, and 5 is the transformer connection. So how do we wire this up? Well, the first thing we're going to do is we're going to wire up the wires from the transformer to the chime, because that's always the first and most sensible thing to do. So what we're going to do is we're going to take 1 wire from the transformer. It's going to travel through the house, and it's going to connect onto terminal number 1. And then we're going to take the other wire from the transformer. And I don't know if they had twisted pair wire in those days, but Earl's a progressive guy and he's got twisted pair wires. Whoops, we went too far. This one goes to number 5. Okay, so the orange wire goes from 1 screw of the transformer to terminal number 1, which is the common, and the purple wire goes from the other terminal on the transformer to terminal number 5, which is the transformer. This gives the chime constant available power all the time. There's 20 volts at the chime all the time because it's wired directly to the transformer. Now we're going to wire up the front door. So from one screw terminal on the front door, one wire, which will be orange, goes over to guess where? It goes over to the common screw, because since it's common, one wire from each pair of wires, because there's one pair here, one pair here, one pair here, and one pair here, so one wire out of each pair is the common wire. So one side of the front door push button is the orange wire, and that goes to the common screw, and the other side, wait for it, where do you think it's going to go? It's the front door button, so what are we going to do? Well, odds are, it's very likely, it's going to go along with its wire, and it's going to drop down, and it's going to connect to terminal number 2, because terminal number 2 is for the front door button. Now, we got to wire the rear door button. So, just like the front, one terminal, orange wire, it goes over and it connects to the common screw, because one wire out of each pair is going to be a common wire. And then the other wire, the purple wire, it goes along with its orange wire, and it's going to drop down and be connected to terminal number 3, because terminal number 3 is the rear door button. And then finally, so we're going to do the side door button. Side door button, just like the other two. The orange wire goes through the house, and it connects to the terminal number 1, which is the common terminal. And the other wire, the purple wire, follows the orange, and it goes down to terminal number 4, because terminal number 4 is for the side door. Now our chime is wired up. This is really all there is to it. The way this works is the chime has constant power from the transformer from its 2 wires connected to 1 and 5. One side of each button, the common side, the orange wire, is picking up power from terminal number 1, which is one of the terminals that come off the transformer. So the transformer is sending power to terminal number 1. It's wired internally to the motor, so the motor can get constant power, but it's also sending power out to one side of each of the buttons. And then when a visitor walks up and pushes the button, the switch closes, it sends power back down the purple wire, and it activates the appropriate door. If you push the rear door button or the side door button, it rings a single note because it energizes just one solenoid for a single note, and it's either this one or this one, depending on how you have it wired up, and they ring differently because the tubes are different lengths. When you push the front door button, what it does is it activates the motor, and the arm on the motor begins to turn, and as the contact point, we should put a contact point right here. As the contact point on the wiper goes across each of these contact points, these red contact points, these are actually called rivets. And we know that because that's what it says in the instructions. As the arm begins to turn, the contact point touches each of these, and it rings the appropriate solenoid. That's how it works. It's actually pretty simple, and it's actually pretty elegant. Now, for those of you who are really paying attention, you might notice that we have 4 tubes, 1, 2, 3, 4, and we know each of them are going to ring twice, so that's how we get our 8 notes. But if you look at the contact points, or excuse me, the rivets, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do we have 9? It's an 8-note chime. I don't know. Well, actually, I do know why. The first 4 are the first 4 notes of the Westminster. The 5th one, which is in the middle, because there's 4 on this side and 4 on this side, the 5th one, it's not hooked up to anything. And the reason that it's there is it gives a pause between the 4th note and the 5th note. and it changes the way it sounds because they were creating an effect. When the chime rings, they wanted it to sound a particular way, and having that brief little pause in between gave them the sound they were looking for. So that's why you have the 9th rivet. That's it. That's how you hook up a 1939 Series 2 NuTone 8-note long tube chime. Pretty simple. Most important thing in all of this is the 20-volt transformer also. It needs to be a 20-volt transformer, and it needs to be 30 watts. If it's more than 20 volts, you're putting a lot of extra strain on the motor and on, not the solenoid so much, but on the motor itself. And if you have an 80-year-old irreplaceable motor, you don't want to take the chance. The other thing about the 30 watts is the watts represents the amount of power or energy available in the transformer. So think of it this way. If you have a little nightlight bulb in your house, it's a little 4-watt bulb. So it's 4 watts. See, watts, 4-watt bulb, 30-watt transformer, it's all watts. So if you have a 4-watt bulb, it's small, it's not very bright, it's 4 watts. If you put a 30-watt bulb in your nightlight, it's going to be 30 watts. Whole lot of light, a lot of power available there. The 30 watts in a transformer represents the amount of available power. The chime isn't going to use all 30 watts, but there are 30 watts available. Think of it as a giant reservoir. It's a giant reservoir. Instead of water, it's a giant reservoir of watts. And the chime is going to draw power or energy out of the reservoir of watts. If the chime wants 5 watts, it's going to use 5 watts. If the chime wants 15 watts, it's going to use 15 watts. And it's always going to work, and it's always going to be fine because in the reservoir there's 30 watts. But what happens if the chime wants 50 watts? Well, you don't have 50 watts in your reservoir, you only have 30. So the chime can't get 50, and then the chime doesn't work right. So if you put in a transformer, let's say you find a 20-volt transformer, but the only 20-volt transformer you can find only has 15 watts. Wrong, not enough watts. Your reservoir is too small, and the chime's not going to work properly. Because what happens is, when you activate the chime for the front door, you begin the motor turning. So the motor uses energy, it uses some of the watts, and then each time it hits a rivet and it fires off a solenoid and a plunger pops out, the solenoid, it needs a big boom of power right now when it's got to hit the tube. So it uses watts also. If you don't have enough watts, the motor will start to turn. It probably would run on 15 watts and it would hit the first rivet. But as soon as the solenoid is energized and the solenoid grabs more watts than are available, the motor is going to stop. And it's not going to keep turning because it hasn't got any watts left. The reservoir is empty. So you don't have any watts available. And that's not good. You need enough watts. You need a big enough reservoir to run the motor and fire off the solenoids and not have everything stall out and stop. And that's kind of the point. So you need to have the proper size transformer. You could, in theory, if you want to take it to an extreme, let's say that this all together, when it's running and everything is working properly, let's say it's using 25 of the 30 watts. So you've got a 5-watt headroom there. You've got extra watts that you don't need. Let's say if we take it to an extreme and you find a 20-volt transformer, but it's rated at 100 watts. So it's a big giant reservoir. 100 watts is a lot. It's more than 3 times what it really needs. That's okay. You can use that. You can use 100 watts. The 100 watts isn't going to force itself into the chime and burn the chime up. It's just a giant reservoir of watts, and then when the chime runs, it's only going to use the 25 watts at once. The other 75 watts are just sitting in the reservoir, not doing anybody any harm. So that's okay. So bigger is good, smaller is not. Classically, my go-to transformer for more modern NuTone transformers are always 30-watt transformers because everything works good on 30 watts. So that's a little bit about the transformer. Sorry, got off on a tangent there a little bit about transformers. People ask me all the time about transformers and they don't really understand it. So I think it's important to talk about that just a little bit. Anyway, that's the ins and outs of how to wire a chime like this. Now that we've talked about it, let's go ahead and get it set up, hang it, put some tubes on it, and see what it sounds like. Now that we understand how the 1939 Series 2 NuTone chime base works and how it should be set up and the things you have to consider when you install it. Here it is installed. It's on our shop Chime testing base, and I've got a set of tubes hung on it. These are not 1939 tubes. I don't have a set of 4 of those. So these are sort of my universal tubes that I use on lots of different types of NuTone chimes. That's why they have extra hanger cords on them, because they fit lots of different kinds of chimes. You'll notice this one right here, the long tube on the left. It's got this black band. That's a piece of tape. A lot of the times the brass tubes, they crack, and it was sort of an attempt to squeeze it back together to improve how it sounds. When they crack, if they crack a lot, they get sort of flat sounding. They make sort of a clunking sound when they ring. So you have to take that into account when this one is rung, because that's the best we have. I'm always looking for a proper set of tubes for each model, but they're hard to come by. So this is what we have to work with. So we'll go ahead. I have it set up. I have the volume adjustment set at, it's a little more than half. I'm going to go ahead and I'm going to set it down to about halfway to start with. And we'll ring the side door. That's this tube. You can hear how it sort of clunks a little bit. It's not horrible, but it's not as good as it should be. And then we'll ring the side door. And now we'll ring the 8 note. And that's probably a little soft, even for an average size house. So we'll go ahead and we'll set the volume up just a little bit more. And for the third and final time, we'll set the volume all the way up to its maximum. And there you have it, a 1939 Series 2 NuTone 8-note long tube door chime. I hope you found this video to be interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube, because that always helps. There'll be a banner right here that shows you how to subscribe to our channel. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.